Mollweid's formula. In Mollweid's formula, we are having two sets. One is, first I will write one, I will prove one of them, and then I will write the second set and I will prove one of them. The first set says that sine a minus b by 2 is a minus b by c cos c by 2. Sine b minus c by 2 can be written as b minus c by a cos a by 2, and sine c minus a by 2 can be written as c minus a by b cos b by 2. This is the first set of Mollweid's formula. Okay, let me just prove one. Let me just prove the first one. I'm starting from the right hand side. A minus b by c cos c by 2. Now again, we know from the sine rule that a by sine a is equals to c by sine c equals to 2 the circumradius of the triangle ABC. Now a can be replaced by cos c by 2. So 2r will get cancelled from the numerator and denominator. So we are left with sine a minus sine b by sine c. So I am applying the formula of sine a minus sine c minus sine d. So we are getting sine c can be written as 2 sine c by 2 cos c by 2. This cos c by 2 goes off, 2 goes off. Cos a plus b by 2 can be written as cos pi by 2 minus c by 2 sine a minus b by 2 divided by sine c by 2. Is it clear to all of you? Why it is pi by 2 minus c by 2? Because we all know that a plus b plus c is 180 degree. So cos 90 minus theta will give you sine c by 2. Sine a minus b by 2 is as it is. Sine c by 2 goes off. So we are left with sine a minus b by 2. Is it clear to all of you? Have you understood this? So we have proved that sine a minus b by 2 is nothing but a minus b by c cos c by 2. Is it clear? So the rest two formulae you can prove by yourself. Now let us just move for the second set of Mollweid's formula. It states that cos a minus b by 2 is Is it clear? So this is the second set of Mollweid's formula. Let me just prove the first one of this set. We are starting again from the right hand side. So a plus b, a can be replaced by 2 or sine a. Two goes off from the numerator and denominator. So we are left in the numerator as sine a plus sine b, which can be written as sine c can be written as 2 sine c by 2 cos c by 2 into sine c by 2 is there. So sine c by 2 goes off, 2 goes off. Again, a plus b can be replaced by 180 degree minus c. So we are left with pi by 2 minus c by 2. Sin 90 minus theta is cos theta, that is cos c by 2. Cos c by 2 and cos c by 2 goes off. So we are left with cos a minus b by 2 is it clear? So what we have proved is cos a minus b by 2 is nothing but a plus b by c sin c by 2. The other two formulae you can prove accordingly. Is it clear to all of you? Now let us move for the sixth basic rule for any triangle is what about areas of the triangle. Area of the triangle is generally denoted by del. We all know that, the first one, we all know that area of any triangle is nothing but half into base into height. This we have all done in class 10 standard. As well as the Heron's formula we have learned, del is nothing but under root into s minus a into s minus b into s minus c, where s is nothing but the semi-perimeter of the triangle. Can you remember it? Absolutely, right? So del, from the Heron's formula we can write the area of the triangle is under root s into s minus a into s minus b into s minus c, where s is nothing but the semi-perimeter, which is a plus b plus c divided by 2. Now, let us try to find out the other formulae for finding out the area. Now, ABC is a triangle. Let me just draw AD perpendicular on BC. Okay? This length is A. That is, the length of BC is A, length of AC is B, and AB is C. Okay? Now, what you can write? Look it carefully. The area of the triangle can be written as half into base into height. So, half, what is BC? BC is nothing but A. And what about your AD? Your AD can be written as C sin B. Is it clear? AD can be written as, from the triangle ABD, AD can be written as C sin B. So, it is C sin B. Is it clear? So, the third formula that we got is nothing but half AC sin B. Is it clear? Now, if we draw a perpendicular from B on AC and from C on AB, we can prove the area as AB sin C as well as BC sin A. Is it clear? Therefore, the area of any triangle can be written as half into the product of any two sides into the sine of the angle between them. Sine of the angle between them. Is it clear to all of you? Okay. Now, look it carefully. Now, if we take that the area of the triangle as, this is the fourth formula for the area of the triangle. We have already done this thing as half AB sin C. Is it clear? Now, sin C can be written as, from the sine rule, it can be written as C by 2R. Okay? So, this can be written as what? ABC by 4R. So, this is also a very important formula for the area of any triangle is ABC divided by 4 into the circumradius of the triangle ABC. Is it clear to all of you? Okay. Now again, let me just find out another formula for the area. A can be replaced as what? 2R sin A. From the sine rule, it is 2R sin A. For B, we can write it as 2R sin B. And for C, we can write it as 2R sin C divided by 4R. Is it clear? So what we are getting? What we are getting? Look it carefully. In the numerator we are getting 8R cube. In the numerator we are getting 8R cube. So which can be written as 2R square sin A sine B, sine C. So this is also another formula for finding out the area of any triangle. What is that? 2r square sine A, sine B, sine C. So we have learned 5 formulae for finding out the area of any triangle. One is what? That the first 2 we have done in class 10 standard, half into base into height, that we all know, as well as we know the Heron's formula, that is under root s into s minus a into s minus b into s minus c, where s is nothing but the semi-perimeter. Then we have learned that the area of the triangle can also be calculated by half into product of any 2 sides into sine of the angle between them. The 4th formula we have learned is nothing but ABC by 4R. What is R? R is the circumradius of that triangle ABC. And the 5th one what we have learned is 2R square sine A, sine B, sine C can also be used to find out the area of any triangle. Is it clear to all of you? This 5 formulae for finding out the area of the triangle we have to remember. Now, the last but not the least is what called your half angle formula. Is what called your half angle formula. Here, sine A by 2 can be written as under root s minus b into s minus c divided by bc, where s is nothing but the semi-perimeter. Similarly, sine b by 2 can be written as s minus a into s minus c divided by ac. Sine c by 2 can be written as s minus a into s minus b divided by ab. We have to all remember this formulae. Okay. Now, let me just prove one. We know that sine a by 2 can be written as what? 1 minus cos a 2 under root. Okay, root I will give later on. Let me just write square over here. Is it clear? So it's 1 minus, tell me, 1 minus cos a by 2. Now from the cosine formula, what is the formula for cos a? B square plus c square minus a square divided by 2bc divided by 2. So what we are getting? BC. So it is coming to what? A square minus b minus c whole square divided by 4bc. Is it clear? So now what we can write? We can write this thing as sine square a by 2 can be written as a square minus b square Is it okay? Now we all know that 2s is nothing but a plus b plus c, where s is the semi-perimeter. So a plus b can be replaced by 2s minus c. So this thing is coming to what? 2s minus 2c, and a plus c can be replaced by 2s minus b, which will give you 2s minus 2b divided by 4bc. Am I correct? So what we are getting, if we take 2 common, so from here 1 2 will come out, from here 1 2 will come out, so it will be 4 goes off. So we are left with s minus b into s minus c divided by bc. Is it clear? Therefore sine square a by 2 is s minus b into s minus c divided by bc. That implies sine a by 2 is under root. Sine a by 2 is nothing but under root s minus b into s minus c divided by bc. Is it clear to all of you? Absolutely. So I have proved this one. The other 2 you can prove with the similar method. Okay. Now the other set of half angle formula is for cos. Cos A by 2 can be written as under root by BC. Cos B by 2 can be written as S into S minus B by AC. Cos C by 2 can be written as S into S minus, it is C by AB. Is it clear? So this is your cos set of half angle formula. I will prove one, the rest two you can prove by yourself. We have already got that sine A by 2 is nothing but under root S minus B into S minus C divided by BC, right? So what will be your cos A? Cos square A by 2 is what? 1 minus sine square A by 2, which gives you 1 minus S minus B, S minus C divided by BC. So BC minus so just open the bracket, you are going to get what? BC, BC goes off. So we are left with what? S square minus BS minus CS minus S square plus BS plus CS divided by BC. Am I correct or not? If I open the bracket, BC is going to get cancelled. So we are left with this. So now if I take S common, we are left with B plus C minus S squared divided by BC. Now let me take S common. So we are left with what? B plus C minus S divided by BC. Is it clear? Now we all know that 2S is A plus B plus C. So what will be B plus C minus S? B plus C minus S will give you S minus A. So this can be written as what? S into S minus A divided by BC. Therefore cos A by 2 will give you what? Tell me fast. Under root S into S minus A divided by BC. That exactly what is the first formula for half angle formula for the cosine set. Is it clear to all of you? So the other two you can prove by yourself. Is it clear? Now the third set also you have to remember, but it's pretty easy to remember. If you can remember this too, the other set we can remember very easily, which is nothing but your tan A by 2. Tan A by 2 will be what? Sin A by 2 divided by cos A by 2. So which will yield what? S minus B, S minus C divided by S into S minus A. Is it clear? Similarly, tan B by 2 can be written as S minus A into S minus C divided by S into S minus B. And tan C by 2 can be written as S minus A into S minus B divided by S into S minus C. Am I correct? Now from here, if we have, this is one set we have to remember. Now we can modify this also in another way. In another form we can get for tan A by 2. So for this what I'm doing, under the root sign I'm multiplying numerator and denominator with S into S minus A. So in the numerator we are going to get divided by, is it clear? So what is the numerator? Numerator is nothing but your del. And in the denominator we are getting S into S minus A. Is it clear to all of you? So for tan B by 2 also you can write it as del by S into S minus B, and for tan C by 2 you can write it as del by S into S minus C. It's another set also you can remember in this way. I mean tan A by 2 formula we have to remember in this form as well as we have to remember by del by S into S minus A. Similarly the other one. Okay. Now we can modify in another way also. These are all modifications doing inside your tan A by 2. So what I'm doing in that case is, in this case, In the previous one, I have multiplied with s into s minus a in the numerator and denominator. Now, if you multiply s minus b into s minus c with numerator and denominator, so in the numerator we are going to get s minus b whole square, s minus c whole square, and in the denominator we are going to get within the under the root sign. So from the numerator we are getting s minus b into s minus c, and in the denominator from the Heron's formula we are getting del. Is it clear to all of you? Absolutely. So this can also be written as s minus b into s minus c divided by del. Similarly, this can also be written as what, tell me? S minus a into s minus c divided by del. This can be written as s minus a into s minus b divided by del. Is it clear to all of you? Absolutely. No question. So all those half angle formulae we have to remember. Remember not by memorizing. Do sums, automatically this thing will be engraved. Is it clear to all of you? So these 7 basic rules we have to remember, okay, to do problems. Now in the next lecture we are going to do problems based on these 7 basic rules. Is it clear?